The last main logical connective we will look at is the conditional, though at the very end of this lesson we will also take a brief look at the biconditional connective that can be constructed from it. And you'll start to see that conditional statements are among the trickiest ones to symbolize. So we'll spend some time setting the rules for how to symbolize some common conditional statements of English. By the end of this lesson, you should be able to identify sentences of English that use conditionals and be able to correctly symbolize them as sentences of propositional logic. And you should be able to do the same for the simple biconditionals we look at too. So the new symbol we're going to introduce is material conditional. And this logical connective is symbolized with a rightward-facing arrow. Like conjunction and disjunction, it links two sentences. This symbol is used to express sentences that mean something like if-then. So examples of sentences that should be symbolized with this material conditional, our new logical connective, include: if Vern gets a cat, he will be cleaning his house obsessively to get rid of hair. Cade likes to hide on Sunday, provided that she doesn't go to the gym. Should Jackie recommend a bill, Hannah will vote for it. When Jackie recommends a bill, Hannah votes for it. Jackie's recommendation of a yes vote will lead to Hannah's supporting the bill as well. And Cade's not going on a hike will result in their feeling lethargy at work on Monday. Before we look at some of these richer examples, we're going to look at a straightforward if-then statement. So our starting example is the classic, if it's raining, then I will bring an umbrella. This statement contains two atomic statements. It is raining, and I will bring an umbrella. And we symbolize this as R, arrow, U, which can also be read if R, then U. There are a couple things to note about the conditional that make symbolizing sentences with it a little bit more complicated than with conjunction and disjunction. Unlike those two connectives, the conditional is directional. This means that the order of the statements on each side of the arrow matters. The sentence that precedes the arrow is called the antecedent, and it puts forward the condition, hence the name conditional. The sentence that follows the arrow is the consequent, the consequence of that condition. It has to be true if the condition holds. The second thing to note with the material conditional, as it's used in truth functional logic, is that it only tells you about what to think about when the antecedent is true. Then you know the consequent should be true. But it doesn't tell us anything about what we should think if the antecedent is false. So in this example, if it's not raining, the sentence has nothing to say about whether I should bring an umbrella or not. Now let's look at some of those other examples that used different kinds of language to express conditionals. For conditional sentences that don't use the straightforward if-then language, you might find it easier to try to paraphrase the English language using the if-then formula in order to symbolize it. So, for example, Cade likes to hide on Sunday, provided that they don't go to the gym, means that if Cade doesn't go to the gym, then they like to hike. So we can symbolize that, as we see below, as not G, then H, where H is Cade likes to hike on Sunday, and G is Cade goes to the gym on Sunday. Both should and when function basically like if. And like with if, the statement that immediately follows should and when is the antecedent, and we can imagine a then there to signal the consequent. So should Jackie recommend the bill, then Hannah will vote for it. When Jackie recommends a bill, then Hannah votes for it. In both of these, we have essentially the same atomic statements. Jackie recommends a bill, Hannah votes for it, and so we get R arrow V. If R, then V. In translating this next example, we benefit again from paraphrasing the original English sentence using if-then to get our symbolization right. So our example goes, Jackie's recommendation of a yes vote will lead to Hannah's supporting it as well. So we've got one statement is R, Jackie recommends a yes vote on the bill, and V, Hannah supports the bill. This sentence means that if Jackie recommends a yes vote on a bill, then Hannah will support it. So we can symbolize that with R as our antecedent and V as our consequent. Now let's look at one last straightforward example. Cade's not going on a hike will result in their feeling lethargic at work on Monday. This conditional expresses cause and effect. Not all conditionals do so, but when they do, the cause should be the antecedent and the effect should be the consequent. So in this case, Cade not going on a hike is the cause, so that needs to be the antecedent, not K. And Cade feeling lethargic is the effect, so that's the consequent, L. We're now going to look at two types of conditional claims that are common in philosophy and can be represented with the material conditional again. Statements of these forms are sometimes used to define or describe complex concepts. So the first is sufficient conditions. So we use this when a condition is sufficient for some outcome, as in, John's 12th place in the marathon is a sufficient cause for celebration. And we can also say that a condition is necessary for some outcome. So taking the final is necessary for getting an A in this course. So let's look at these two examples. If we have John's 12th place in the marathon is sufficient cause for celebration, that means that if John gets 12th place in the marathon, then we have a cause for celebration. So we can generalize from this. If A is a sufficient condition for B, that means that if A is the case, then B is or will be the case. So again, we're paraphrasing to get the right symbolization. And that gives us if A, then B, for A is a sufficient condition for B. Necessary conditions are perhaps a little less intuitive because they reverse the direction of sufficient conditions. But again, we'll see that paraphrasing in the if-then language makes their proper symbolization a bit clearer. So our example was, taking the final is necessary for getting an A in this course. What does that mean? It means if you get an A in the course, then you took or must have taken the final. If we generalize from this, we get, if A is a necessary condition for B, it means that if B is the case, then A must also be or come to be the case. So if A is a necessary condition for B, that means if B is the case, then A is the case. The phrase only if is another one that signals that we need to symbolize a sentence with a conditional. But it's important when doing so that we distinguish only if from just if, or if then. So only if would appear in a statement like, the Senate will pass the bill only if the House doesn't. This statement means that if the House passes the bill, the Senate won't. So we can symbolize that as if H, then not S. If the House passes the bill, then it's not the case that the Senate will. To get to our general rule for how to symbolize only if, we're going to move from this example to an equivalent symbolization and then to our general rule. So in the middle here we note that if H then not S is equivalent to if S then not H. We'll be able to prove this a little later, but for now you're going to have to take my word for it. So this second symbolization means that if the Senate passes the bill, then the House didn't. This is not a perfect paraphrase of the original meaning, but it roughly captures that if the Senate passes the bill, then it must be the case that the House didn't. As with some of our other logical connectives, the conditional doesn't capture everything about what this English sentence means, but it is rich enough to capture the roles that sentences like this play in arguments and reasoning. And that's what we're interested in this course. So this second symbolization draws out what is counterintuitive about symbolizing only if. The statement that follows only if is the consequent rather than the antecedent. So in general, A only if B should be translated with if A, then B. Unless is another one that tends to trip people up. So an unless sentence would be something like, the Senate will pass their version of the bill unless the House passes their version of the bill. So we've got S, the Senate passes their version, H, the House passes their version. What does this English sentence mean? We can again paraphrase. If the House doesn't pass their version of the bill, then the Senate will pass theirs. We can express that with if not H, then S. So from this we can generalize A unless B can be translated with if not B, then A. I'll just note that the text offers a couple of alternative equivalent ways of symbolizing statements with unless. This happens to be the one I find the clearest, but I would obviously accept any equivalent way of symbolizing. Our final use of the conditional is going to be in defining the biconditional. So the biconditional is a phrase like if and only if. This phrase is common in technical definitions, some of which we see in logic. And it's commonly shortened to if with two F's. So if you see IFF, that means if and only if. So here's an example where we define what conjunction is. A conjunction is true if and only if both conjuncts are true. So there are two atomic statements involved in this biconditional. C, a conjunction is true. B, both conjuncts are true. The biconditional as a whole means if a conjunction is true, then both conjuncts are true. And if both conjuncts are true, then the conjunction is true. That might have gotten a bit confusing, but the important thing is that the biconditional is the conjunction of both directions of the conditional. So we have if C, then B, and if B, then C. So generalizing, anytime you see A, if and only if B, that can be symbolized as if A, then B, and if B, then A. But that's pretty long, and if and only if is pretty important. So because of its significance to logic, the biconditional is often given its own symbol, the double-headed arrow. That is just a shorthand for this longer biconditional, the conjunction of both directions of the conditional. And with that, you are now equipped with all the logical connectives we're going to use to symbolize sentences of English in propositional logic. So starting in the next part of this unit, we'll examine the logical significance of these connectives in a bit more detail. But first we have to get into a few more of the weeds of symbolization, including how to properly construct complex logical formulas from atomic statements and these 5 connectives.